Hello friends, so today's question: two blocks connected by a massless string slide from an inclined plane having an angle of inclination of 37 degree. The masses of two blocks m1 is 4 and m2 is 2 kg respectively, and the coefficient of friction of m1 and m2 with the inclined plane are 0.75 and 0.25 respectively. Assuming that string to be taut, find the common acceleration of two masses and the tension in string. So this is the figure. M1 and M2 are connected by string. The angle of inclination is given 37 degree. Okay, and we are going to find out what will be the common acceleration as well as the tension in the string. So first of all, let us say that the tension in the string is given by T. Okay. And the common acceleration with which they will be moving in the downward direction is given as A. We say that common acceleration of M1 and M2 is given as A. So let us draw the free body diagram for both the blocks separately. So we have this is our M1 and the downward direction there will be tension T. The angle of inclination is given at 37 degree. So as it is moving in downward direction, we are going to have a friction, let us suppose frictional force rather, F1 in the upward direction, and there will be M1G. So let us draw the normal, that is given as N1. So we have this angle as 37. So we have the one component will be our M1G cos of 37 and another component will be our M1G sin of 37. Okay. So there will be two components. We can write F1 for mass M1. You can say T plus in the downward direction. I forgot to mention that the downward direction acceleration is A. So we can say that our M1A will be equal to M1G sin of theta plus T and minus of F1. And we can find out our F1. F1 will be equal to mu into N1 and N1 will be equal to our M1G cos of 37. So we can say mu M1G cos of 37. We substitute the value of F1. We get this as M1A is equal to M1G sin of theta plus tension T minus F1 is mu M1G, sorry, not 37 theta but 37. M1G cos of 37. Let us call this equation number 1. And similarly we can draw for M2 also. So we have M2 there will be tension T in upward direction and there will be M2G and the components. Let us call this a normal N2. This will be 37 and 37. So component will be M2G cos of 37, and here will be M2G sine of 37. And it is also moving in downward direction with the acceleration A. So you can say for mass M2, we can write the equation as M2A will be equal to M2G sine of 37, and in the upward direction there will be F2, friction force, okay, and minus T minus F2. And we can find out our F2. F2 will be equal to mu into N2. N2 will be equal to M2G cos of 37, so we get mu into M2G cos of 37. We substitute the value, we get M2A is equal to M2G sine of 37 minus T minus mu M2G cos of 37. Question number 2. Okay, so we can solve equation number 1 and 2, okay, and or we can say simply adding 1 and 2, it will be much more easier. Adding equation 1 and 2, we get, let me write equation 1 first of all. We have M1A is equal to M1G sine of 37 plus T minus mu M1G cos of 37, and equation 2 is M2A is equal to M2G sine of 37 minus T minus mu M2G cos of 37. So T cancels out, we get A as common, M1 plus M2, and here we can put G sine 37 common, that G 37 M1 plus M2, and here it will minus G cos 37 common, G cos 37, and this will be M1 plus M2. So we can see our acceleration A, we can take G M1 plus M2 common, G M1 plus M2, and we have sine of 37 minus cos of 37 divided by, mu1 and mu2, my mistake. The coefficient of friction is different, so this will be mu1, and we can add this mu2. mu1, and where else? Yeah, mu1 mu2, that's correct. Okay, so this will be G cos, this will be mu1, and this will be mu2. Sorry. So we can write A is equal to G sine of 37 M1 plus M2 minus G cos of 37 mu1 M1 mu2 M2 divided by m1 plus m2. This is our acceleration. Now we put the values. G is our 9.8. Sine of 37 is given us as 0.6, and m1 plus m2 is 4 plus 2. G is 9.8. Cos of 37 is given as 0.8 and 0.75 into 4 plus 0.25 into 2 divided by 4 plus 2. So if we solve it, we get our acceleration A as, it will be coming as 1.3 meter per second. Okay. So this is the common acceleration. You can say common acceleration for m1 and m2. And in the second part, we are supposed to find out the tension. Okay. We can use the equation that T is equal to m2g sine of 37 minus mu2 m2g cos of 37 minus m2a. We put the values. m2 is 2 into 9.8. Sine 37 is given as 0.6. Mu2 is our 0.25. m2 is 2. 9.8. Cos 37 is our 0.8. Minus m2 is 2. Into a is 1.3. So this T will be coming as 5.24 newtons. This is nothing but tension in the string. Tension in the string. Yeah. Let's complete the question. Thank you.